Here we go. So there's this graph right here. This graph talks about the estimated number of scripted shows. So I kind of like this. So in the year 2002, there were 132 scripted shows on broadcasts, on broadcast TV. So like ABC, NBC, all those things. And then starting the year 2009, there started being online shows. So like Hulu originals and Netflix originals and things like that. There was one show in 2009. And then in 2010 there were 4, in 2011 there were 6, in 2012 there were 15, and so on. We want to figure out how we could model that data to figure out how many there are going to be in the future. All right? So we take our calculator, and we're going to go stat, edit, and we're going to type in this information. So let me clear this stuff out. Clear, enter, over up to L1, clear, enter. I'm typing in that data. It's starting the year 2009. So 2009, we're going to call year 0. So what would I call the year 2010? That's year 1. It's years since 2009. So basically, just add 2009 to 2000. It's 2 more years. From 2009 to 12, it's 3 years. 9 to 13, it's 4. It's 5. It's 6 years to 2015. So 2016 would be 7 years. Okay, it's 7 years from the starting year. Okay, that's the concept that we're dealing with there. Don't let that be hard. So this column right here is going to be my L1. That column right there is going to be my L2. So for L1, I'm going to type that in, 0, 1. Type in all my data. Then I'm going to go to L2. I'm typing in all of those. $93. Okay, we got all my data. Once I've typed in all that data, what am I going to do to look at that picture? Zoom, and we're going to go down on zoom to get down to zoom stat, which is always zoom 9. You can hit enter, and you should see some dots. I got this little line here. That's just from earlier. I can clear that out and go back to zoom 9. There are my dots. Does that graph look linear right now? Does it look like a straight line? No, linear is not going to be a best choice because it's not being linear. It starts kind of linear, but then it's really ramping up there. So if it's not linear, it's normally one of 2 options, okay? Our 2 options are going to be, is it quadratic or is it exponential? Okay, that's what we're worried about now. We are trying to decide which type of regression is it. Is it a quadratic regression? Is it a parabola-looking thing? Or is it exponential, more of a rocket ship kind of thing? And to decide which one it is, we're looking at our R-squared values. So to figure out which one it is, I'm looking at my calculator, and I'm going stat, over to calculate. Which one am I picking to figure out if it's a quadratic regression? Number 5. Go down to number 5. I hit enter. I'm going to go down to calculate and hit enter. There is my data. Which one of those things tells me if it's a good model or not? R squared. My R squared is this 0.951 number. Okay? 0.951 is my R squared value. Is that a good model for my data? Yeah, that's pretty good. It's not perfect, but it's pretty good. The closer to 1 it is, the better it is. So quadratic was 0.951. That's great, but we want to check to see if exponential's better. So now we're going to hit stat again, over to calculate, down to which one gets me exponential. Down to 0. So down here, 0 is exponential regression. I'm going to hit enter. Go down to calculate and hit enter again. I got 0.955 for this answer. 0.9, what was it? 55? 2 5s? There's my R squared for that one, 0.955. I'm looking at the R squared. Don't look at the R value. We're looking at the R squared value, 0.955. Which was a better representation of my data? Was it R squared, or was it exponential, or was it quadratic? Exponential was better. This was the better option because that R squared value is closer to 1. That's a better model of my data. So that's the one I'm picking. I'm picking the R squared data. Okay, I'm picking the one that was closer. It's exponential. So once we've made that decision, we're going to write down our regression equation. This is our regression equation. This is that screen I just had up. That's the formula. Something times something to the x power. That's the equation. A times b to the x. My A is this, 1.74. Times my B is this, 1.80. So 1.8 to the x power. We can look at that if we want to look at it. I'm going to hit the y equals button, and I'm going to type in that equation right there so I can just get a better feel for it. Oh, no. Sorry. Sorry. That's really annoying. 1.74 times 1.8 to the x power. Look at my graph. That line makes sense. It's getting pretty close to my data. It's not right on top of it, but it's close. What would I want to do to predict how many online shows will there be in 2018? Plug in. What am I going to plug in for X if I want to know how many there will be in 2018? 9, because I'm going from 2009. So basically, 2009 plus what? Get you 2018. X is 9. So I'm going to type that in. I'm going to go 1.74 times 1.8 to the 9th power. I'm going to plug in a 9. This is what people do all the time. They're trying to figure out how many shows there are. They think by the year 2018, there'll be 345.1, so we'll call it 345 shows on Hulu. I would guess that's probably not enough. My kids watch the Netflix originals. There's like 10 billion Netflix kid shows now. It's crazy. I'd suggest Super Monsters. It's really good. Yeah, Super Monsters. Not the bug one. Anyone seen that bug one where they just play Beatles music? That's a weird one. Are we good on this? Everybody understand that? Okay, pull out your whiteboards for a second. Let's do just a quick thing here. On the board, you've got 3 graphs. I want you to write 1, 2, and 3 on your whiteboard for me. For number 1, so this graph right here, you have one of 3 choices. Is number 1 quadratic, no correlation at all, or linear? One of them is quadratic, one of them is no correlation, and one of them is linear. Write 1, 2, and 3, and pick which one of those representations is quadratic, which one of those representations is nonlinear, or I'm sorry, is no correlation, and which one is linear. This first one, what would you best draw to match number 1? A straight line. Would that line be positive or a negative correlation? Negative. It's going down. So like the more time you spend on the treadmill, the less your weight would be. That would be the kind of negative correlation there. Number 2, it's quadratic. Something like that. It could also kind of be exponential, but it kind of pops back up there. So quadratic's probably better. And number 3, which way would you draw your line? You can't draw a line. This one's called quadratic because you can draw a parabola-looking shape. Remember, parabolas are quadratic functions. Same idea here, 1, 2, and 3. I'm giving you 3 R-squared values. When I plugged these 3 things into my calculator, I got these 3 values. Your job is to predict which one had each R-squared value. So number 1 had which R-squared value. Number 2 had which one, and number 3 had which one. Use your brain. Try to think about that. If I'm asking this question, what am I really asking here? How good is the line? How strong is the correlation? Which one of these has the strongest correlation? The first one. It's a really tight line. So if it's the strongest correlation, which R-squared value does it have? The one that's closest to 1. That one's going to be the one that goes there. Which one has the second best correlation, would you say? Number 2, this one, the dots are going downward. You can definitely tell there's some sort of pattern. So it's going to have the second strongest value, 0.78. The third one is a cloud of dots that don't really do a whole lot. So that one is going to be the 0.343. It might not even be that strong of a correlation. I would say it's probably even weaker than that. Questions on something there? The only other thing you got to be able to do is draw a best fit line by hand and be able to find that pretty straightforward, and then do a linear correlation on your calculator. All right, we're going to practice that now, so I'm going to pass out the review, and that's what you're going to work on.